this plant? It's so alive. I wonder, where did it come from?
This rock feels ancient, like it's been here since the beginning of time.
And this water, it's been here since forever, right? How did it even exist?
Oy, 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 what are you all doing?
We're just curious. Where did everything come from? The plants, the water, the rocks, even us?
Hey there, Asipai Pips! Have you ever stopped for a second to ask yourself, where do we really come from? Like, how did everything, the sun, the moon, the planet, even us, come to be?
For many religions, like Christianism for example, the answer is simple. A divine creator made the heavens, the earth, and all living things. But today, we'll explore a different kind of story. The one written not only on holy books, but on the stars themselves. Because today, we're basing on facts, on science.
Our story begins 13.8 billion years ago with one of the most mind-blowing events in the history of everything, the Big Bang.
Big Bang theory was first proposed by a Belgian priest and astronomers named Georges Lemaitre in 1927.
He called it the hypothesis of the primeval atom, the idea that the universe began from a single, tiny, hot, dense point that suddenly expanded to create everything.
Others call this singularity or super hot massive ball, and it just kept expanding.
At first, not everyone believed him. Even Albert Einstein doubted it. But later, when an astronomer Edwin Hubble discovered in 1929 that galaxies were moving away from each other, Einstein admitted Lemaitre was right.
That expansion didn't stop. Even today, the universe is still growing. Hubble's discovery became known as Hubble's law, which supports the idea that the universe is continuously expanding. Lemaitre was influenced by both his faith and physics. Naniniwala siya na ang siyensya ang nagpapaliwanag kung paano nabuo ang universe, habang ang relihiyon naman ang nagpapaliwanag kung bakit ito nabuo.
As the universe began to cool down, something amazing happened. The super hot massive fragments from the explosion, full of electric charges, started to slow down and become particles.
These particles, protons, neutrons, and electrons began to collide and combine.
Over time, they formed the first simple elements, the what they call lightest elements: hydrogen, deuterium, tritium, helium, and a bit of lithium.
Yeah, that means the first 3 seconds after the Big Bang were basically the universe version of instant noodles. Fast, hot, and explosive. Mabilis, mainit, pero pasabog naman ang mga nangyari.
This process, the formation of first element, is called Big Bang nucleosynthesis. Let's see what happens step by step. Step 1. Hydrogen formation. The simplest elements. 1. Proton and 1 electron. Boom! Hydrogen is formed.
Step 2. Hydrogen isotopes. Some hydrogen atoms gain extra neutrons, forming deuterium, tritium. These are the siblings. Hydrogen, some element, different number of neutrons.
Step 3. Helium formation. Deuterium and tritium combine forming helium. The second lightest element, also the one used to make balloons float.
Step 4. Lithium formation. Helium and tritium fuse together to make lithium, the lightest metal and the element found in the phone battery.
Then, gravity started to pull these atoms together, forming clouds of gas and dust. And when those fragments collided again, they formed larger clumps, the building block of stars, planets, comets, and asteroids.
Those same cosmic leftover from the Big Bang are what makes up everything today, from the air you breathe to the stars you see at night.
The nuclear reaction stopped, and matter began to gather. From here, the stage was set for something brighter, the birth of stars.
Now that the universe had its first ingredients, it was time to cook up something new.
Millions of years later, huge clouds of hydrogen and helium gas started to come together under the force of gravity. When they got dense enough, their cores heated up to about 15 million Kelvin, that's over 26 million degrees Fahrenheit.
And then, tada! The first stars were born. Inside these massive glowing furnaces, a new process called stellar nucleosynthesis began.
Stellar means star and nucleosynthesis means making element inside the nucleus.
This story was developed by a brilliant British astronomer named Sir Fred Hoyle in the late 1940s and early 1950s.
Hoyle noticed something interesting. If the Big Bang only produced hydrogen and helium, then where did all the other elements on Earth come from? Where did carbon, oxygen, iron, or gold come from?
Fred Hoyle was influenced by the discoveries in nuclear physics during the World War II. At that time, scientists had learned how atoms could be split or fuse, and Hoyle applied that knowledge to explain how stars make elements naturally.
Hoyle explained that inside a star's core, hydrogen atoms fuse to form helium, just like in our sun. Then, as the star gets older and hotter, helium starts fusing into carbon, oxygen, and other heavier elements.
Wow! Imagine that! A single star is creating so many elements, from beryllium to iron. That's why stars are often called the factories of the universe.
Did you know that iron is the most stable element in the universe? But why? When a star reaches iron, fusion stops. No more elements can form inside it.
That's when something epic happens. Stars starts to lose balance, and that leads to one final spectacular event, the supernova.
When a massive star runs out of fuel, its outer layers collapse under gravity, and the result is one of the most powerful explosions in the universe, a supernova.
This idea was further explained by Fred Hoyle and William A. Fowler, who discovered that during a supernova, temperature reached about 100 billion degrees Celsius.
That's so hot that atoms smash together again, forming even heavier elements from cobalt all the way to uranium.
Fun fact, the heaviest natural element, uranium, was created in supernova explosions.
Everything heavier than uranium like plutonium is called the transuranium element. They don't occur naturally. Scientists create them in laboratories or nuclear reactors.
After the explosion, the star scatters its new elements into space, becoming part of nebulae, giant clouds that form new stars and planets.
So basically, every explosion helped build a new world.
That's right. When stars die, they don't just disappear.
They give birth to a new stars, new planet, and new life.
Let's take a step back and think about this cosmic story.
The Big Bang created hydrogen and helium. Stellar nucleosynthesis builds elements after iron, and supernova nucleosynthesis created everything heavier from gold to uranium.
So when you look at the night sky, remember this. You're not just looking at the universe, you're looking into yourself.
Because every atom in your body was once part of a stars. You, yes, you are literally made of a stardust.
From the stars we came, to the stars we shall return.